Hello guys. So in this video, we will be talking about Hashmap, how Hashmap works internally. Okay. And this is also one of the most commonly asked interview question for the Java developers. Okay. So let's start with it. So Hashmap is one of the most commonly used data structures, right? Hashmap is basically a collection which stores the data in the form of key value pairs, right? Now, what is key value pair? So let's understand with the help of example. Let's say I want to store the programming languages in Java. So how can I store it? In this way, right? So here key is the key one with the value Java. Key is the key two with the value C++ and so on, right? So here hash map is a combination of two things, key object and value object. Here key objects are key one, key two, key three, which are strings, and values are Java, C++, Python, again, which are string. Okay. And it the inserting data into hash map, which is a get operation, and getting sorry inserting data into hash map, which is a put operation, and getting data back from hash map is the get operation, and it's normally take O1 time. Sometimes it takes more than O1, and we'll see those cases, right? Now hashing. Let's see what is hashing. So hashing is the process. Basically, why do we need hashing? So let's first understand that hash map is a data structure, but internally it uses array, right? And when we write hash map h equals to new hash, that is when we initialize hash map, it creates an array of 16 size, which is a by default size. It creates an array of 16 size. Okay. Now, when we store data in hash map, so when we store hashmap dot put hashmap dot get hashmap dot put key one Java. So what does it do? It stores this data into array. Now, where it would storing, I mean, at what index did key one and Java would go, for this hashing is used. Okay. So what's the role of hashing here? So basically, hashing takes care of hashing the key and getting the index where that value will be stored. And we'll see this with the help of example also. Right, so hashing is a two-step process. First step is converting object into hash code, and this object is key object in case of hashmap. Okay, the second step is generated hash code, then determine the index of the array where the object is stored. Okay, so first step is generating the hash code, and second step is using a formula that we'll see later. And using a formula with the hash code, it generates the index where the actual Java value will be stored in the array. Okay. And also, I would ask you to please go and see my video on hash code and equals. I have attached the link in the description, and it will be helpful. And we will see hash code and equals in this video later on. Okay, so understanding the hashing with the help of examples. So I mentioned hash code is a two-step process. First is generating the hash code, and second using a formula determine the index. Okay, so let's say there's a key name hello and we want to store it in the hash map, right? So first step, as we discussed, is generating the hash code. So let's say hash code is this 3373707 with the binary representation is okay. Now second step is using this hash code and using a formula. So this is the formula we're talking about. It's a bitwise operation between hash code, bitwise and n minus 1. And as I've already mentioned, when we initialize the hash map, it creates an array of size 16. So this 16 is n. Okay. So n minus 1 is equals to 15, which is boundary is 1111. We simply apply this formula, hash code, bitwise n 1111, and which will result into 1011, which is 11, right? So with the key name hello, with the hash code this we have mentioned, it would store this hello key, basically the value with the hello key at the 11th position in the 11th index in the array, right? And this is what hashing is. Okay. Okay. So now, how does hashmap stores the data in this array, right? So hashmap does not store just the value. So it stores the a node object. It's a class. It's a node class object. And what does it have? It stores four things with it. One is the integer hash. For every key, it creates the hash and stores it. Key object, the value object, and the pointer to the next object. Let's just not confuse with this, and we'll see what this pointer is. Okay, the example would be this. So this is the array of 16 size. Let's say hello is the key with this hash 3533 and it stores it at the first index, right? And at fifth index, we have the world key, which this hash. Okay. So now don't get confused with this. Now first let's understand the collision case in hashmap. Okay. So when we are trying to put something in hashmap, what we are doing, we are generating the hash code of the key. And it's possible that hash code of two keys can be similar, right? And if hash code is similar and we are getting index from this formula, index would also be similar, right? So let's say for world and world 2, here you can see hash code are similar, and if hash code would be similar, the indexes would be similar. So now for these two objects, hash index is 5. So what should we do? So Java has figured there is a way at this index, basically at every index there can be linked list. There can be multiple objects, and how to store multiple objects. Before Java 8, Java uses linked list, and after Java 8, it uses balance tree if the node in the linked list exceeds 8. Okay. Okay. So let's simplify it a bit. So at first position, there is only one object. So this pointer that we have seen, this pointer I'm talking about, this pointer is pointing to null because there is no next object in this list. Okay. At sixth position, that is the fifth index, there are two objects. So first world is next pointer is pointing towards world 2, right? Because there are two values are stored with the same hash, right? So this is what hashmap is. Okay. Now let's see how put and get operations are done. So for put, we compute the hash code for a key. We use the hash code to find the index of the bucket or the array. If there is no collision, we add the new node. If there are collision, we use a linked list or tree since Java to resolve it. So this is what I'm assuming now things are making much more sense. When we are putting, we have seen at this position there is no node, so we simply added this node at first position. For this, let's say this world 2 does not exist and world does not exist. And when we try to insert world and 34, it sees at fifth position no node, so we simply add the node here. When the world we are trying to add world 2 and 245, it says the node already exists, so we add the node and mark the next pointer to this node. So this starts forming linked list now. Okay. And how the get operations works, we compute the hash code for a key, we go to the bucket. If there is only one node, we simply return the value. If there are multiple nodes, it iterate the linked list and find the object, right? So let's say it tries world 2, right? So it calculates the hash code and it reaches the index. So it knows world 2 will be at a fifth position. But at fifth position, there are two nodes. So it iterates the linked list and figure out where the world 2 is. Okay, moving ahead. Now, I've already mentioned hash code and equals previously also. So hash code is determining the bucket. I'm assuming it's clear. Using this hash code and the formula, we are reaching here at what index my node will be. But at fifth, there can be multiple nodes. In this example, at fifth position, there are multiple nodes. So now it is using equals to match the object, right? So if the two objects are equal, their hash code should also be the same. And hashmap ensures that same hash codes are checked using equals to avoid duplicates, right? Because what do we mean by duplicates here is, we have seen, each key has to be unique here, right? So when we try to put hashmap.put key1 Java, if we try to put again key1, so it knows that hash codes are similar, then it checks with object with equals, that it compare Java with the value and it understands that both keys are same or different, right? So moving ahead, collision handling, we have already seen it. If the when multiple keys are mapped to same bucket, they form a linked list or tree. For basically from Java, it starts using a balance tree if the entries in the bucket exceeds 8 for performance. Now resizing. So I've already mentioned that hash map, when we initialize a hash map, it creates an array of size 16, right? So, and the default value, so basically when it will be resized, right? So, well, the numbers of objects in the hash map can be greater than 16, it can be 100, it can be 200. So, when the load factor, which is the default of 0.75, that is when the hash map exceeds 75% of the capacity of the array. That means for 16, if the number of elements exceeds 12, that is when the 13th element inserts, it doubles the size of the array. So when we are trying to insert the 13th object, 13th value in the map, it increases the size of array from 16 to 32, from 32 to 64, and so on, right? And it also needs to rehash all the keys, right? So why rehashing is important during resizing? I mean, it's pretty straightforward, and we'll see with this example. We have seen index was calculated using this hash code and n minus 1. When the n changes, the n minus 1 also changes. So for the keys which were already present, when we trying to get it, we will not be able to get them if we don't rehash. And we will see this is an example. So initially with the index 16, we have seen this, the index was 11. After we resize the size is 32, for same when we apply the formula is 27. So when we trying to get it, it will give us the value of the 27th index and not the 11th index. And hence we need to rehash all the objects, all the keys, right? And this is how we can change the load factor and the size. So it is initializing the hash map with 16 size and zero point 0.5 load factor, right? I like to mention few important points about hashmap here also, that hashmap is not sequential. So let's say I insert key 1, then key 2, then key 3, and when I say print the hashmap, the order could be anything, right? And if you want to maintain the order, there is one more data structure, linked hashmap. We'll see one more video on how linked hashmap works internally and how it's maintaining the order. And one of the main use case of linked hashmap is LRU cache, right? Another is कि hashmap is not thread safe. So please refrain from using hashmap in the multi-threaded environment. Instead, use concurrent hashmap. Okay. That's it, guys. That's it for this video. If you feel anything can be improved or anything else you want to know, please feel free to comment. I'll definitely reply. Thank you.